everyone, very welcome to my presentation, which will be about artificial intelligence in the continuous integration testing, the current stage, and also the future trend. My name is Sahar Tahvili. I'm an operational team leader at Ericsson. Also, I'm a researcher at Malvern University. I have background in applied mathematics and computer science with the focus of testing and test optimization using different AI technology for improving the testing process. I'm doing applied research. Usually, we are working with different companies. Right now, it's just Ericsson. I have with me Leo Hatvani, my colleague from university, he's a lecturer, and we do together applied research in different fields of testing and AI. Today, I'm going to divide the talk in two main topics. First, let's review what is the software testing, why testing is important, what is the history of software testing, and how we can improve the testing by employing different AI technologies. What we can get as a benefit if we combine these two topics. Are these two topics are already combined or not, and how we can use it in the real life. I'm going to show a short demo, one example that we make a prototype on that at Ericsson for test automation, and later I can explain why we make it and what is the benefit of that. As a tester, our main goal is to reduce the risk. Before we release the product, doesn't matter if it's a software, hardware product, before we release the product to the market, we need to find the hidden bugs in the system as much as possible, as soon as possible. If we review the definition of testing, the aim of the software testing, as I said, is to detect the hidden bug and be sure that the product is bug-free before sending it to the market. But what will be happened if we are not investigating enough money and effort on the testing? Unfortunately, there is catastrophic stories, we know that, and it still can happen if we are not paying attention to the testing. Testings in this regard can be considered as an important and critical stage in the software development life cycle. The studies show that more than 50% of the assigned budget to the development goes just for the testing. It's a costly process, still is human dependent, and we need to have people who are having knowledge in the testing domain to increase the quality of the product. From the beginning, early 80s, we start doing everything manually. Testing was manually, which means we write the requirements manually, we write the standards manually, we write the test cases manually, we map the test cases and requirements manually, and we executed the test cases manually. So you can assume how much it will take time and cost. Even during the time, we developed different methodology for doing the testing. But one aim we had from the beginning until now, automation. How we can reduce the human work, at the same time, how we can increase the quality. We are not just going to minimize the time and effort just because we want to release the product faster to the market. We need to send the good quality product to the market. So automation from the beginning in the testing was a golden key that how we can achieve it. And we tried different methodologies. We tried different things up to today. The same story happened with AI, more or less. We started with a very basic machine. We tried to use electrical machine. We tried to use internet and knowledge-based system. Then we ended up to having AI. When we face IoT, big data problem, cloud infrastructure. Again, one golden keyword in the AI history is automation as well. That's why these two topics has one common purpose. They then became as one strategy, having AI and testing with the goal of automation. But it's not just about using AI technology for testing. It's also testing AI algorithms before we release the algorithm to the market. We need to be sure that there's application for this algorithm. It's not just a cool algorithm, okay, let's develop it. Is there any application for that? Can we use it in the real life, at industry or not? So that's why two main questions will be satisfied by having these two as a one topic. using AI for improving the testing process, also testing AI applications. If we check the trends of AI software testing in past years, we will see there is a lot of overlap between AI and software testing. Machine learning for log analysis, using AI technology for test automation, which is the most important topic for us at industry. Also optimizing the testing process by using AI technology, which means we can reduce the number of test cases for execution. We can rank them in a more efficient way. It's not necessary that all test cases that we generated for testing a software is important. Some of them are redundant, but why we should create them from the beginning? Let's analyze the requirement. Which test case should be created? Which requirement has higher priority for us? In that sense, AI helped a lot using different machine learning and deep learning model for scheduling the testing process and also for test automation, which is a main focus of this talk. At Ericsson, in my group, we are working with testing and verification in the telecom domain. Although we are not in the mobile device market anymore, but we are working with infrastructure, cloud infrastructure, radio baseband infrastructure, microwave link infrastructure. More mobile device require more radio base station, more network base station, and we are working on that. Beside of in developing 4G, 5G, and the next generation of the networks. Today I'm gonna show a short demo of one prototype that we make at Ericsson for test automation called NASTIC. It stands for Using Natural Language Specification for Test Case Generation. NASTIC is in earlier stage, still we are developing it. We did just a proof of concept. We filed a patent based on our results. Just we measured the accuracy of the model and the time saving that we can have by using NASTIC before we go to the next step. NASTIC has three main steps, mostly related to text analysis. But why? Just because all the input, all the test cases, all the requirements that still we have in the telecom domain are written in natural text by human. So we should use a tool which is able to read, parse, and analyze the text written by human, which could be a lot of misspelling, which could be a lot of completely the quality of a test specification depends on the skill of the people, of the testers, the language skill, the testing skill, and having the knowledge in the domain. So it will be hard for the tool to analyze that kind of the text. That's why we add different steps to the model that non-structured text can be converted to a structured text, which is machine readable. But what is the output? In this case, the output will be C# code. And the input is test specification written in English, but the tool is able also to analyze other languages. We need just to develop it, but since the input in our case at industry, it was in English and the output is C# code, we train the model by these two input and output. Otherwise, there is no limitation. We can have different text in different languages, and also the output could be Java code, any other type of code. Here I have one example of a test specification extracted from our database. As you can see, everything explained manually, described manually, the parameter, the criteria, the requirements, what you need to do, step by step, written by the text. So this text, but it's not readable for a machine, as this format. Although we remove some irrelevant information. Not necessarily all information that we have inside of a test specification is relevant for making a test script. Also, of course, it could be relevant for other purposes, but not for this purpose. We need to find the keywords. Which keywords are important for us for making a script from this text? How we can extract them? How we can remove irrelevant words? That's why, as a first step, we have data preprocessing, which contains different steps like stop words, removing irrelevant information, detecting the relevant information, and the output will be feature vectors. So before we go for classification, before we go to assigning any script to the text, we need to detect the important words inside of a test specification. I have a very simple example here for you. Assume the algorithm detects these three words: time, calculate, and voltage is important. Of course, this is a simple example, just because usually a test specification is more than 5 pages, and you can assume the keywords could be more than 100. But it's a simple example. We have these three words, and then we can map these three words with some of the existing C# code that we have in our database. But it's not like that these three words come in this order always. It could be just 2 of them, 1 of them, all 3, and any combination of those. So assume you have 100, you have thousands keywords, then you can imagine how it should be big, right? But still the algorithm should be able to detect. It doesn't matter in which order they come and how many times the algorithm faced them. It should be able to detect them. This screenshot is just a sample of test script. Just for these 3 words, the algorithm detects this script from A to Z should be assigned for these 3 words. And we have a confidence score that we measure how the algorithm, how the tool is sure about the output. Every time that we are talking about optimization, at industry, everyone asks how much you can save. But we should consider what is the accuracy of the model. AI is expensive by itself, right? It takes time. You need to train the model. You need to gather the data. How much we can save? Of course, a lot. But what is the accuracy? Can we trust the results, or is it just we did something cool? We measure just for the current version of the tool, which we trained it on 11 different base stations for 4G and 5G products. The accuracy is close to 90%. Of course, we are working on it. We need to reach it, 100%. That is the goal. Let's see. But the time that we saved at the same time, we measured just for one example. One test specification, 5 pages. If you are a senior tester and you have good knowledge, a strong knowledge regarding testing and telecom, it takes 5 hours for you, more or less, between 4 and 5 hours, to generate a test script based on a test specification. Reading it line by line, coding it, debug it, etc. But it takes just 35 seconds for the tool to generate and show which test script is corresponding to this test specification. Of course, the accuracy is 90%. We need to improve it. We know that. But minimizing the time from hours to seconds encourages us to invest more on the tool. Even it takes time to train the model. Even it takes time to gather more data. But let's invest on it. And we make a prototype of that, and hopefully in the future we are going to make a real product. So here I have a short demo that it will read a test specification as an input, written in natural text, the same example. And then we are going to have suggested, still we call it suggested test script until we reach 100% accuracy one day. And also the confidence score, how the tool is sure about the results. So for this example, one test specification, we got 2 test scripts. For one of them, 100% confidence score, which means you can just go and execute this test script. There's no discussion about that. The second one, it was above 100%, 89. For that one, of course, we need to do some manual work. We need to check it. Maybe something wrong with the input, which is case in most of the time that we are checking why the confidence score is low. When we check the quality of the input, even we apply different NLP model, is still not good enough for the algorithm. The algorithm is not able to read it just because it's a human work and it might be a lot of mistake inside of the document. And we need to invest more on that part. Another thing is like maybe the algorithm should be trained with more data and we need to retrain the model. But even there is something wrong in the test specification or the test script has a lower confidence score, still we can modify it even manually. Assume 4 hours to 35 seconds. Even we change some parameter manually in the script, still this script is ready for execution faster compared to writing it from scratch. So that's why we are still working on it. So if you find the things that I presented here interesting, so let's join us. We are looking for different skills. In my department, we are looking for data scientists that, at Ericsson, we are working with innovation a lot and also research, and it's not just development. But we have this opportunity to train our algorithm on our own data, and it will be faster for us to release the algorithm, even the new algorithms, to the market. So that's all for me. So let me know if you have any question. Thank you.